All right, this is a quick recap of electron configuration, and it's meant to supplement the two videos or the video that I've had you watch on electron configuration. So the purpose of this video is to just put a little bit of information, some learning from that tutorial on electron configuration into your notes. So you're going to want to copy this out. Now, electron configuration. So the quantum numbers tell us they're basically kind of like an address for the electrons. As you move from the primary quantum number to the secondary quantum number to the tertiary and the quaternary quantum number, it gets more and more specific about where the electron is located in the atom. So the quantum numbers of electrons also correspond to locations of the atom on the periodic table. So you can determine what orbitals the electrons are found in based on the position of the atom on the periodic table. So I've drawn a couple diagrams here for you. Now, I'm going to talk about the diagram that we see on the right first, something that looks like the periodic table. Now, the position that the atom is in on the periodic table tells you the location of the outermost electron. So the last electron that the atom has. So depending on where it is, so as you can see, I have the periodic table kind of color-coded to show you different blocks. So if it's highlighted in pink, this is the S block, and it is telling you that the last electron in the atom is found in an S orbital. Now remember that the N tells you the energy level that of the electron, so it also corresponds to the period. So the period tells you which energy level or that the electron it is, how far away from the nucleus you can find the electron. And then the block that I have color-coded here tells you the orbital of the last electron. So when I am figuring out electron configuration, I often like to find the position of the last electron and then fill it in, fill the rest in by going backwards. So if your electron is found over here, the atom, is found over here, then the last electron is found in the P block. And here is the D block, and then down here is the F block. Now, in the video that you watched, he showed you a little annotation where he drew a little chart with some arrows to show you the way to fill orbitals. What you see on the left side of this page is another version of that. Now, in his looked a little bit less confusing than this one, but the way that the one I've drawn works is that you start down here at the 1s and you move up in the direction of the yellow arrow, and then you follow the pink back down to the bottom of the next yellow arrow and you move up through the 2s. So if you follow the line, you still are moving in the direction that you have to fill, or the order that you have to fill the orbitals. That's just one way, but another way is to use your periodic table. And I will talk about that in a second. Now, something else that I'm pretty sure the video talked about, but maybe not for sure, is that each of the orbitals have a maximum number of electrons that can fit in the orbital. So the s orbitals can only hold 2, and that actually should really make sense to you, because when you look in the S block, I'm going to highlight this, there is only 2 spots in the S block. And your p orbital, it can hold 6, And that should make sense because if you count in your groups across in P block, there is 6 columns. And then D block, across the D block, there's 10 columns. And in the F block, if you count, there's 14. So the maximum number of electrons that can fit in a orbital corresponds to the size of the block on the periodic table. So you always should be able to remember. Now, another thing I want you to look at in this note here, and I have provided you with a page that you can print out this periodic table that you see, because it is showing you the exact position of all of the electrons. And so if we go to maybe figure out an electron configuration for nitrogen, and we know nitrogen has 7 electrons. You can find nitrogen on your periodic table, and if you do, I'm just going to change my color maybe to red here. If you do, you're going to find nitrogen right here. So you look and you can see that so nitrogen is found in 2p3 right here. So when I said work backwards, I said find it on the periodic table and then fill in the rest. So it's found at 2p3. So we know it has to have filled 2s at 2s2, and it had to fill 1s. So it has 1s2. It's that easy. The other thing you can do, and I'll do this one with argon here. Argon has, if you look on your periodic table, has 18 electrons. So our argon is found right here. Okay. So I like to find it. The other thing I like to do is I can find it, and then I just start rhyming off all of the spaces I had to go through. I start here and I go 1s2. Sorry, my stylus sucks. 2s2. I filled completely 2p6. I filled 3s2, and then I'm just following numerically across the periodic table, and I get all the way over here to 3p, and it's at 3p6. So that means that the 1s orbital is full, the 2s orbital is full, the 2p orbital is full, the 3s orbital is full, and the 3p orbital is also full. Okay. And so now we will look at nickel. So nickel is found, if you look on your periodic table, it is found right here. Okay. So to get to this point, again, you can either work backwards, and you can come up here to this little thing that we have drawn at the top of our note, and you can see that it's in 3D. So if I'm in 3D right here, everything else has to be filled. So everything else I have to fill. So I have to fill 1s. I have to fill 2s. I have to fill 2p and 3s. I have to come back. I have to fill 3p and then 4s. And then finally, I can come back to 3D. This is where it gets a little bit confusing because there's actually some overlap happening between some of our orbitals. And in some cases, the s orbital gets filled before you finish off filling the d orbital for that energy level. But if you follow the periodic table, you won't make a mistake. 1s2, 2s2, to fill 2p6, 3s2, 3p6, 4s2, and then 3d8. So that is our electron configuration for nickel. And then I gave a really long one here, terbidium. This one is pretty complex because I want you to notice that when we start dealing with the F block, there's a lot of overlap happening. So we fill 5p before 6s and then before 4f8. And that's because the periodic table, if you look, the F block actually does fit in right in here. And you'll notice that the atomic numbers go that way as well. So always follow the atomic numbers to help you figure out which orbitals go first in terms of filling them. All right, so now the video also showed you abbreviation. And so we're going to look at 2 here. Now, scientists can be really, really lazy, and writing something out like terbidium, that's a lot of work. So we can short form that. And I have an example right here. If I get the electron configuration for sulfur, and you figure it out in your periodic table, it's 1s2, 2s2, 2p6, 3s2, 3p4. Instead of writing all of that out, what you can do is use the symbol for the preceding noble gas in a square bracket, and then you follow it by what is in between. So what is left? So in my example right here, what's highlighted in the pink box, this is the electron configuration for neon. So it's basically been replaced by the symbol for neon in a square bracket. And then I just have to continue with 3s2 and 3p4. So that's kind of like a scientist lazy man way of doing it. And another example would be calcium and tin. I've just got a couple abbreviated electron configurations there for you. And then the last thing, and I don't think the video talked about this, but we're going to look at it quickly, is that you can have an electron configuration for ions. So my example here is phosphorus. The electron configuration for phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. If we abbreviate it, it's neon 3s2, 3p3. But the phosphorus ion has actually gained 3 electrons. So because it's gained 3 electrons, that last block that we see, or that last orbital, it did have 3, but now it has 3 more. And so the phosphorus ion has an electron configuration ending with 3p6 because it has 3 more electrons. And its abbreviated version is no longer Ne3s2 3p3 because it now has the exact same configuration for an argon atom. So this is the end of looking at electron configuration. And in the next little lesson, we're going to look at electron energy diagrams, which you've actually already seen in the electron configuration tutorial that you watched before this lesson. So just make sure that you have this whole video into your notes and do some practice. The best thing you can do is to use your periodic table and follow the atomic number, and you will never get it wrong.